Welcome to the Advanced Carbon Footprint Management and Reduction Professional course, presented by CDG Training. This program is designed to equip you with the skills needed to manage and reduce carbon footprints effectively. Every action we take leaves a footprint. From the energy we consume to the products we manufacture, our actions contribute to greenhouse gas emissions. Organizations worldwide are now prioritizing carbon management as a strategic business initiative. Welcome to this transformative journey with CDG Training. Understanding why carbon footprint management matters is crucial. Identifying sources, improving efficiency, ensuring accountability, and setting sustainability goals are key steps. As shown, organizations are increasingly adopting carbon management programs. Carbon footprint management involves measuring, analyzing, monitoring, and reporting emissions. By understanding these components, organizations can effectively reduce their environmental impact. The global transition toward low-carbon economies is underway. Investments in decarbonization and climate action are increasing, signaling a shift toward sustainable practices. Explore strategies for carbon reduction and decarbonization, from energy efficiency to renewable resources. Each strategy plays a vital role in reducing emissions and achieving sustainability goals. ESG, sustainability, and climate leadership are integral to modern business strategies. Integrated ESG and carbon management drive long-term resilience and investor confidence. Technology and smart carbon monitoring are revolutionizing how we track emissions. From AI to blockchain, these innovations provide transparency and efficiency in carbon management. In this course, you'll learn about GHG accounting, decarbonization, sustainability reporting, and more. These modules will equip you with the knowledge to assess, strategize, implement, and continuously improve carbon management practices. CDG Training is committed to providing practical knowledge, strategic insight, and global standards in sustainability education. Join us in leading the way toward a sustainable future. Your journey starts now. With the Advanced Carbon Footprint Management and Reduction Professional course, you'll be equipped to lead in sustainability and carbon management. Welcome to the advanced course on carbon footprint management and reduction. Here, you'll gain insights into carbon accounting, climate change, emission reduction, and sustainability leadership. Climate change involves long-term shifts in temperatures and weather patterns, primarily due to greenhouse gas emissions. Let's explore its impacts, from rising temperatures to economic disruption. The greenhouse effect is a natural process where atmospheric gases trap heat, leading to global warming. Human activities like industrialization and deforestation accelerate this effect. Each greenhouse gas contributes differently to global warming. Here, we identify key gases like CO2, CH4, and N2O, and their global warming potentials. A carbon footprint measures the total greenhouse gas emissions associated with an entity or activity. It includes emissions from organizations, products, services, and individuals. Effective carbon footprint management is crucial for organizations aiming for sustainability and competitive advantage. It supports climate action, regulatory compliance, and investor confidence. The GHG protocol categorizes emissions into three scopes: direct emissions, indirect energy, and value chain. Scope 3 often represents the largest share of an organization's carbon footprint. Carbon accounting is the systematic process of measuring and reporting greenhouse gas emissions. It forms the foundation of all carbon management activities. Carbon dioxide equivalent, CO2e, provides a universal measurement unit for comparing greenhouse gases. It enables standardized reporting and consistent carbon calculations. Identifying where emissions originate within an organization is crucial for effective reduction strategies. Key sources include electricity, transportation, and manufacturing. A structured assessment ensures comprehensive and actionable emissions data for decision-making. It involves defining boundaries, identifying sources, and developing reduction strategies. Organizations can reduce their carbon footprint through energy efficiency, renewable energy, and sustainable procurement. Continuous improvement is essential for long-term success. Renewable energy sources like solar, wind, and hydropower are key to decarbonization. Green hydrogen and biomass systems offer additional pathways to sustainability. Carbon neutrality and net zero represent different levels of climate ambition. Net zero focuses on reducing emissions as much as possible, with offsets for the remainder. Carbon offsets allow organizations to compensate for emissions by funding projects that reduce or remove greenhouse gases. They complement direct emission reductions. ESG performance is crucial for reducing regulatory risks and enhancing sustainability. Carbon management plays a key role in improving ESG scores and attracting investors. Climate-related risks can impact financial stability and operations. Effective carbon management is key to building organizational resilience. Technology is transforming carbon management, enabling faster and more accurate climate action. Innovations include AI, blockchain, and advanced analytics. As climate commitments grow, the demand for skilled carbon management professionals increases. They play a crucial role in accounting, reporting, and strategy development. In this chapter, we've covered the essentials of carbon footprint management, from climate science to ESG strategies. Remember, accurate measurement is key to meaningful climate action. Explore the essential frameworks for greenhouse gas accounting and carbon reporting, focusing on standardized accounting, global reporting, and disclosure frameworks to build investor confidence. Carbon accounting standards are crucial for ensuring consistency in measuring and reporting emissions. They enhance credibility, comparability, compliance, and investor confidence, while providing accurate climate reporting. Greenhouse gas accounting is vital for quantifying emissions and understanding their impact. It involves measuring emissions, identifying sources, establishing baselines, tracking progress, and supporting reduction initiatives. The Greenhouse Gas Protocol is the leading framework for carbon accounting, developed by WRI and WBCSD. It provides guidance on emission measurement, comprehensive reporting, and climate strategy development. The GHG Protocol aims to measure consistently, improve transparency, support climate action, enable benchmarking, and enhance communication for effective carbon management. Defining organizational boundaries is crucial for accurate emissions reporting. The equity share and control approaches determine how emissions are reported based on ownership or operational control. Operational boundaries classify emissions into scopes 1, 2, and 3, ensuring comprehensive reporting across all emission sources. Scope 1 emissions are direct emissions from owned or controlled sources, including company vehicles, industrial boilers, manufacturing equipment, and on-site fuel combustion. Scope 2 emissions result from the purchase of energy, such as electricity, steam, heating, and cooling, and are crucial for organizational energy decisions. Scope 3 emissions occur throughout the value chain and often represent the largest share of an organization's carbon footprint, including goods, services, commuting, and travel. Scope 3 emissions are categorized into upstream and downstream activities, covering purchased materials, transportation, waste management, and more. ISO 14064 provides internationally recognized guidance for greenhouse gas management, ensuring consistency and credibility in carbon reporting across sectors. Carbon reporting is a strategic imperative for demonstrating leadership, meeting stakeholder expectations, and driving meaningful climate progress. Organizations engage in carbon disclosure programs to demonstrate climate leadership and meet investor expectations, enhancing stakeholder trust. Accurate carbon reporting relies on robust data collection systems, including utility bills, fuel records, travel records, supplier information, and production data. Emission factors convert activity data into emissions, crucial for accurate carbon accounting across electricity, fuel, transportation, and waste. Independent verification enhances confidence, transparency, and stakeholder trust, reducing reporting risks and ensuring accurate disclosures. Organizations face challenges in data availability, scope complexity, stakeholder engagement, and regulatory changes, requiring systematic solutions. Technology is transforming carbon accounting with automated reporting, AI analytics, real-time tracking, blockchain verification, and digital platforms. Carbon management professionals are essential for emission measurement, climate reporting, compliance, ESG disclosures, and reduction planning. This chapter provided a comprehensive understanding of greenhouse gas accounting frameworks, standards, and practices, emphasizing the importance of accurate carbon reporting for climate action. Accurate carbon footprint management relies on reliable data collection and scientifically sound calculation methodologies. Organizations need to effectively reduce greenhouse gas emissions by understanding where emissions originate, how much is emitted, and which activities contribute most significantly to their overall carbon footprint. Carbon footprint calculations transform operational activities into measurable emissions using activity data and emission factors. As regulatory requirements, ESG reporting expectations, and climate commitments grow, organizations are increasingly expected to demonstrate transparency and accuracy in carbon reporting. Reliable carbon footprint assessments depend on accurate information. Poor data quality can lead to incorrect conclusions and ineffective climate strategies. Organizations should prioritize data accuracy and consistency across all reporting activities. Improved reporting accuracy ensures credible and precise data. Better decision-making is driven by high-quality data, leading to informed sustainability strategies. Regulatory compliance requires accurate records to meet environmental regulations. Stronger ESG disclosures are supported by transparent and reliable reporting. Effective reduction planning relies on measurable emission reduction initiatives. Activity data refers to measurable operational information used to calculate greenhouse gas emissions. It serves as the foundation of all carbon calculations. Without accurate activity data, emission estimates become unreliable and carbon strategies lose credibility. Activity data captures the scale and intensity of operations that generate greenhouse gas emissions. It is collected from day-to-day business activities and converted into emission estimates using appropriate emission factors. Common examples include electricity consumption, fuel usage, transportation distance, and waste generation. Organizations collect various categories of activity data across their operations. Each category captures a distinct dimension of emissions-generating activity and requires tailored data collection approaches. Energy data includes electricity consumption, natural gas usage, and heating fuel consumption. Transportation data covers vehicle mileage, fuel purchases, and air travel distance. Operational data involves manufacturing output, production processes, and equipment usage. Waste data encompasses waste disposal quantities, recycling activities, and waste treatment methods. Carbon footprint assessments typically rely on two types of information. Understanding the distinction between primary and secondary data is essential for managing data quality and reporting credibility. Primary data is collected directly from organizational operations and provides the highest level of accuracy. It includes utility bills, fuel purchase records, and production logs. Secondary data is obtained from external databases and published sources, used when primary data is unavailable or impractical to collect. It includes industry average emission intensities and government statistical datasets. Primary data is always preferred, but secondary data is used when direct measurement is not feasible. Organizations gather carbon-relevant information from multiple internal and external sources. Integrating data from diverse systems improves completeness, reduces gaps, and supports comprehensive carbon accounting across all emission scopes. Utility invoices provide direct consumption data for Scope 1 and 2 emissions. Procurement systems capture fuel, materials, and goods that generate emissions. Accounting records offer financial data for spend-based emission estimates in Scope 3 categories. Fleet management systems and supplier reports enable accurate transportation emission calculations. Environmental monitoring equipment provides real-time emission data for industrial processes. Emission factors are the critical bridge between operational activity data and greenhouse gas emissions. An emission factor represents the amount of greenhouse gases emitted per unit of activity, enabling organizations to convert operations into standardized carbon estimates. Fuel combustion, electricity consumption, and transportation are key areas where emission factors are applied. Emission factors simplify carbon calculations and are widely used across greenhouse gas accounting programs, including the GHG Protocol, ISO 14064, and national regulatory frameworks. Carbon calculations generally follow a straightforward formula that forms the basis of most carbon accounting systems worldwide. Emissions equals activity data times emission factor. This methodology is applied consistently across all emission scopes. For example, electricity consumed, kWh, multiplied by the relevant emission factor, kilogram CO2e per kilowatt-hour, yields the total CO2e emissions. The same logic applies to fuel combustion, transportation, and all other emission-generating activities. The formula is essential in converting raw data into meaningful carbon metrics. Emission factors are available from numerous credible sources. Organizations should always use recognized, up-to-date emission factors to ensure reporting credibility and comparability across periods and peers. Government agencies provide country-specific emission factors for electricity, fuels, and industrial processes. Environmental regulators maintain comprehensive emission factor databases for compliance reporting. International organizations like the IPCC and UNFCCC provide globally recognized emission factors used in national inventories and corporate reporting. Industry associations offer tailored emission factors for specialized processes and technologies. Electricity consumption is often one of the most significant emission sources in an organization's carbon footprint. Unlike fuel combustion, electricity emission factors vary considerably depending on how and where power is generated. The energy mix, including coal, gas, nuclear, hydro, wind, and solar, affects the emission factors. Geographic location also plays a role, as emission factors differ between countries and even between regional grids within the same country. Grid characteristics, such as transmission losses and marginal generation units, influence the effective emission factor. Renewable penetration, with high renewable energy penetration typically yielding lower electricity emission factors, is also crucial. Fuel combustion generates direct greenhouse gas emissions classified under Scope 1. Each fuel type has a unique emission factor reflecting its carbon content and combustion characteristics. Organizations use fuel-specific factors when calculating direct emissions from owned or controlled sources. Diesel is widely used in heavy transport and industrial equipment, with a higher carbon content than other fuels. Petrol is used for light-duty vehicles and small engines. Natural gas is used for heating and power generation, offering lower CO2 per unit of energy than liquid fuels. LPG is used in heating and some vehicle fleets. Coal is the most carbon-intensive fuel, while biofuels, derived from biological sources, offer lower emissions for both combustion and land use change impacts. Transportation emissions represent a significant emission source across Scope 1, 2, and Categories 4 and 9. Accurate transportation emission calculations require selecting the appropriate method based on the mode of transport. Road transportation offers the highest flexibility, using either fuel or distance methods. Rail transport has lower emissions, often using a grid-dependent emission factor. Air travel has the highest emission intensity per kilometer, with a radiative forcing multiplier. Maritime shipping handles large cargo volumes, using either fuel consumption or distance methods. Business travel contributes meaningfully to organizational carbon footprints and is typically reported under Scope 3, Category 6. Organizations strengthen their climate commitments by tracking and reducing travel-related emissions. Air travel, with long-haul flights, has the highest emission factors. Hotel stays generate emissions based on energy use and services. Rental vehicles contribute emissions based on vehicle type and distance traveled. Rail transportation, with a variety of grid-dependent emission factors, typically has lower emissions than other modes. Waste management activities generate greenhouse gas emissions across multiple pathways. Accurately accounting for waste-related emissions requires understanding the different treatment methods and their associated emission profiles. Landfills produce methane, a potent greenhouse gas, with emissions significantly higher than CO2. Incineration generates CO2 and other greenhouse gases, with energy recovery offering emission reductions. Waste transportation emissions are typically calculated using fuel consumption or distance-based methods. Treatment facilities, including composting and anaerobic digestion, have distinct emission profiles. Methane emissions from landfills are particularly significant, and organizations should prioritize waste diversion strategies to minimize these emissions. Organizations worldwide are increasingly expected to measure and manage their greenhouse gas emissions. This chapter explores the importance of assessing organizational carbon footprints and developing emission inventories as a critical component of sustainability management. Understanding organizational carbon footprints involves measuring emissions across various operational dimensions. This includes operations, energy use, transportation, and supply chains. It's the first step toward meaningful climate action. Carbon footprint assessments transform environmental responsibility into strategic action. They help quantify emissions, establish baselines, identify hotspots, support sustainability goals, and meet reporting requirements. Emission inventories are crucial for transparency, climate planning, regulatory compliance, stakeholder communication, and performance monitoring. They provide a structured record of greenhouse gas emissions. Before calculating emissions, organizations must define reporting boundaries. The choice of boundary method, whether equity share or control, significantly influences reported emissions. Operational boundaries are defined to ensure comprehensive and consistent reporting. Scope 1, 2, and 3 emissions cover direct operations, purchased energy, and value chain emissions, respectively. Scope 1 emissions are direct emissions from sources owned or controlled by the organization, such as fuel combustion and company vehicles. Scope 2 emissions result from purchased energy consumed by the organization. Energy efficiency improvements can significantly reduce these emissions. Scope 3 emissions occur throughout the value chain and are often the largest portion of an organization's carbon footprint. Managing these emissions requires supplier engagement and lifecycle thinking. Identifying emission sources is crucial for comprehensive carbon footprint assessments. It ensures no significant source is overlooked, improving inventory completeness and stakeholder credibility. Emission sources are categorized for easier management and reporting. Consistent categorization improves year-over-year comparisons and trend analysis. Accurate data collection is essential for reliable carbon inventories. Organizations should establish structured data collection procedures to ensure quality and consistency. Activity data represents measurable operational information used in greenhouse gas calculations. Accurate data improves reporting accuracy. Emission factors convert activity data into greenhouse gas emissions. Standardized factors improve consistency across organizations and reporting periods. A structured inventory supports climate management programs and provides a comprehensive emissions profile. The development process follows a clear, sequential methodology. Carbon baselines represent the organization's emissions during a selected reporting period. They are essential for setting targets and measuring progress. Carbon hotspots are activities contributing significantly to total emissions. Identifying hotspots allows organizations to focus on high-impact reduction opportunities. Proper documentation supports transparency and verification. Strong documentation improves audit readiness and strengthens reporting credibility. Quality assurance ensures inventory accuracy. Organizations reduce risks associated with inaccurate reporting by implementing robust QA/QC procedures. Verification involves independent review of carbon inventories by third-party assurance providers. It enhances credibility, stakeholder confidence, and compliance readiness. Organizations face challenges in developing and maintaining carbon footprint assessments. Addressing these challenges requires structured management systems and continuous improvement. Modern carbon management relies on digital technologies to improve efficiency, accuracy, and visibility. Digital tools provide deeper insights into emissions performance across all operations. This chapter provided a comprehensive foundation for understanding and implementing organizational carbon footprint assessments and emission inventory development. A well-developed emission inventory is the foundation of every successful carbon reduction strategy. As organizations focus on climate action, understanding product carbon footprints becomes crucial. These footprints encompass emissions throughout a product's lifecycle, from raw materials to disposal. This comprehensive approach helps quantify emissions and identify reduction opportunities. A product's carbon footprint measures total greenhouse gas emissions across its lifecycle. This includes stages like raw material extraction, manufacturing, packaging, transportation, product use, and end of life. Each stage contributes to the overall climate impact. Conducting product carbon footprint assessments offers strategic and operational benefits. These include improved transparency, competitive advantage, and enhanced customer confidence. Operationally, it aids in sustainable product development and supply chain optimization. Lifecycle thinking in carbon assessment shifts focus from single activities to comprehensive environmental impacts. This holistic approach ensures that reducing emissions in one area doesn't inadvertently increase them elsewhere, supporting informed decision-making. Understanding the stages of a product lifecycle is essential for comprehensive carbon assessment. These stages include raw material extraction, manufacturing, distribution, use phase, and end of life, each contributing to the overall carbon footprint. Raw material extraction significantly impacts product emissions. Choices in material selection and sustainable sourcing can reduce emissions across the lifecycle. Mining, agriculture, forestry, and chemical extraction are key areas to consider. Manufacturing generates emissions through energy consumption, fuel combustion, industrial processes, and equipment operation. Improving manufacturing efficiency can significantly reduce these emissions. Transportation and logistics emissions vary by mode. Road transport offers flexibility but moderate emissions, while air freight is fastest but has the highest emissions per kilogram. Optimizing transport choices can reduce carbon footprints. Packaging contributes to emissions across its lifecycle. Sustainable packaging solutions and circular approaches can support climate goals by reducing emissions from production, manufacturing, and disposal. The use phase often represents the largest portion of lifecycle emissions. Energy efficiency improvements in appliances, vehicles, and equipment can significantly reduce these emissions. End-of-life emissions can be reduced through circular economy strategies like recycling and recovery. These approaches support sustainability by minimizing waste and maximizing resource use. International standards like ISO 14040 and GHG protocols support carbon footprint assessments. These standards ensure consistency and credibility across industries, guiding organizations in their sustainability efforts. Assessment boundaries define which lifecycle stages are included in carbon footprint calculations. Choosing the right boundary, such as cradle-to-gate or cradle-to-cradle, significantly affects results and comparability. Functional units provide a basis for comparing carbon footprints by quantifying the function delivered by a product. Accurate definition is crucial for reliable assessments and comparisons. Data collection is vital for accurate carbon footprint assessments. Defining data requirements, collecting primary and secondary data, and ensuring quality checks are essential steps in the process. Emission factors convert activity data into greenhouse gas emissions. Selecting appropriate factors improves assessment quality, ensuring accurate and reliable results. Carbon hotspots are lifecycle stages with the largest emissions. Identifying these hotspots helps prioritize reduction efforts, focusing resources where improvements are most impactful. Comparative assessments support sustainable product development by evaluating materials, manufacturing methods, packaging options, and transportation systems. These insights guide decision-making for lower carbon alternatives. Product carbon reduction strategies involve redesigning products and processes to lower emissions. Strategies include sustainable material selection, renewable energy adoption, and manufacturing optimization. Carbon labels and environmental claims communicate product carbon information to consumers, supporting informed purchasing decisions. Transparency and credibility in these claims enhance stakeholder trust. Product-level emissions are now part of broader sustainability and ESG frameworks. Investors and customers are increasingly evaluating product sustainability performance, and product carbon data strengthens environmental transparency. ESG reports integrate carbon data into environmental performance sections of annual disclosures. Supply chain reporting involves Scope 3 emissions data from suppliers across the value chain. Climate risk assessments focus on physical and transition risk assessments required by TCFD and similar frameworks. Investor disclosures include product sustainability data to evaluate climate and long-term value creation. Modern product carbon footprinting relies on digital technologies. Technology enhances efficiency, accuracy, and scalability, while digital transformation accelerates carbon management practices. LCA software offers specialized tools for lifecycle assessment. Carbon calculation platforms provide real-time data on carbon impacts. Digital product passports embed carbon data to identify opportunities throughout the supply chain. AI-powered analytics enable emission reduction opportunities and improve data quality at scale. Organizations face significant challenges in conducting product carbon footprint assessments. Effective methodologies and robust management systems help address these challenges, and continuous improvement strengthens assessment quality over time. Data availability is a primary issue, with data often difficult to obtain. Supply chain complexity involves multiple suppliers across geographies, requiring comprehensive data collection. Product diversity poses challenges in conducting individual assessments. Emission factor selection requires expertise and careful judgment. Boundary definition is crucial for determining which processes to include in assessments. This chapter explores the full landscape of product carbon footprinting and lifecycle carbon assessments. It covers product carbon footprint fundamentals, lifecycle carbon assessment methodologies, and product lifecycle stages. It also discusses product carbon standards, data collection approaches, and carbon hotspot analysis. Strategies for carbon reduction, carbon labeling, and reporting are included, along with digital tools and challenges in technology adoption. The chapter emphasizes the importance of effective methodologies and continuous improvement for meaningful emission reductions. Understanding carbon emissions is crucial for effective carbon management. Organizations must identify major emission sources and implement strategies to reduce emissions and support long-term climate goals. Carbon reduction involves actions to decrease greenhouse gas emissions while maintaining operational efficiency. Key strategies include energy efficiency, renewable energy, process improvements, transportation optimization, and waste reduction. Reducing emissions offers benefits across environmental, financial, and strategic dimensions. Organizations that actively reduce emissions gain competitive advantages and support both sustainability and business resilience. Decarbonization involves transitioning from high-carbon to low-carbon activities. It is a major component of global climate strategies, focusing on reducing fossil fuel dependency, improving energy efficiency, increasing renewable energy use, and supporting net zero goals. Effective carbon management follows a structured hierarchy, prioritizing direct reductions before offsets. Organizations achieve greater climate impact through proactive reductions at the source. Organizations begin reduction planning by identifying major emission sources. Carbon hotspot analysis helps prioritize actions, allowing resources to focus where the greatest reductions are possible. Energy efficiency is often the most cost-effective reduction measure available. It provides immediate environmental and financial benefits, making it a priority action in decarbonization strategies. Buildings are a major source of energy-related emissions. Optimizing building energy efficiency can significantly reduce carbon footprints and provide rapid returns on investment. Industrial efficiency reduces both emissions and production costs, supporting long-term sustainability. Key strategies include equipment upgrades, process optimization, and heat recovery systems. Renewable energy is a key decarbonization strategy, significantly reducing Scope 2 emissions. Organizations integrate renewable energy into climate strategies to enhance sustainability. Solar energy is a fast-growing renewable technology. It reduces emissions, lowers energy costs, and improves energy independence, supporting long-term sustainability. Wind power provides low-carbon electricity at scale. Organizations increasingly purchase renewable electricity from wind resources, supporting corporate climate commitments. Fuel switching replaces high-carbon fuels with lower-carbon alternatives, reducing emissions. This strategy is integrated into long-term decarbonization plans for greater impact. Transportation significantly contributes to emissions. Sustainable transportation programs support emission reductions and are prioritized for their impact on Scope 1 and Scope 3 emissions. Electric vehicles are crucial in decarbonization strategies, reducing emissions and improving environmental performance. Organizations increasingly adopt EVs as a core climate action. Many organizations reduce emissions within their supply chain through strategic procurement. Collaboration improves Scope 3 management, enhancing overall climate impact. Waste management and circular economy principles reduce emissions and improve resource efficiency. Organizations benefit from environmental and economic advantages. Carbon reduction often requires behavioral change at every level of the organization. Employee engagement strengthens climate programs, achieving significant reductions through awareness and participation. Targets provide direction and accountability for climate action. Clear targets support strategic planning and ensure organizations maintain momentum toward their long-term climate commitments. A decarbonization roadmap outlines how emissions will be reduced over time. Structured planning improves success rates significantly, ensuring effective climate action. Performance monitoring is crucial for effective carbon reduction. By tracking emissions, energy consumption, and renewable energy usage, organizations can adjust strategies based on data to meet climate goals. Organizations face several challenges in implementing carbon reduction programs. Financial constraints, technology limitations, data quality issues, supply chain complexity, and organizational resistance all play a role. Addressing these challenges is key to achieving net zero emissions. Future carbon reduction efforts will leverage advanced technologies like AI, smart energy systems, and renewable energy technologies. These innovations will enhance emission reductions and improve climate management capabilities. This chapter summarized key topics on carbon reduction strategies, decarbonization pathways, and tools for meaningful climate progress. It covered emission reduction principles, energy efficiency, transportation sustainability, and more. The global shift towards a low-carbon economy is crucial for sustainable development. As climate change concerns grow, businesses and communities are seeking alternatives to fossil fuels and carbon-intensive technologies. This chapter delves into renewable energy systems, clean technologies, and strategies for transitioning to a low-carbon future. A low-carbon economy minimizes greenhouse gas emissions while supporting sustainable growth. Organizations are adopting strategies with low-carbon objectives to remain competitive and resilient. Key areas include renewable energy, energy efficiency, clean transportation, sustainable manufacturing, and circular economy practices. Renewable energy is vital for reducing dependence on fossil fuels. It supports both environmental and economic sustainability, offering cleaner air, energy independence, and resilience. Benefits include lower emissions, improved energy security, reduced pollution, and long-term climate resilience. Renewable energy comes from naturally replenishing sources. Solar, wind, hydropower, biomass, geothermal, and ocean energy form the foundation of a sustainable energy future. These sources provide significant environmental benefits over fossil fuels. Solar energy is a rapidly growing renewable technology. Photovoltaic panels, solar thermal systems, utility-scale farms, and rooftop solar are key components. These systems convert sunlight into electricity, driving adoption across all scales. Solar energy offers numerous advantages, including zero operational emissions, reduced electricity costs, scalability, and minimal maintenance. These benefits make it a compelling choice for organizations pursuing carbon reduction goals. Wind energy converts kinetic energy from wind into electricity. Onshore and offshore wind farms, along with distributed wind systems, provide cost-effective and sustainable electricity generation. Wind power offers low operational emissions, large-scale generation, renewable resource availability, and reduced fossil fuel dependency. It supports national climate targets and sustainability commitments. Hydropower generates electricity through the movement of water and is a major contributor to global renewable energy production. Large dams, run-of-river facilities, and pumped storage systems provide reliable baseload power. Biomass energy utilizes organic materials as fuel to generate electricity, heat, and biofuels. It includes agricultural residues, forestry byproducts, organic waste, and energy crops, contributing to carbon reduction strategies. Geothermal energy utilizes heat from beneath Earth's surface, providing reliable and continuous renewable energy with low emissions. It supports electricity generation, industrial heating, and building heating systems. Green hydrogen is produced using renewable electricity and offers a clean fuel alternative for various sectors. It supports transportation, industrial processes, energy storage, and power generation, contributing to a sustainable energy future. Energy storage systems balance supply and demand, enhancing grid stability and supporting energy transition objectives. Technologies include lithium-ion batteries, flow batteries, hydrogen storage, and thermal storage systems. Smart grids improve energy management through digital technologies, enhancing efficiency and reliability. They enable real-time monitoring, demand management, renewable integration, and automated controls, supporting low-carbon energy systems. Electrification involves replacing fossil fuel-based systems with electricity-powered alternatives. It significantly reduces emissions and is a core decarbonization strategy, including electric vehicles, heating systems, and industrial equipment. Organizations can access renewable energy through on-site generation, power purchase agreements, renewable energy certificates, and utility green energy programs. These strategies help achieve sustainability goals and reduce emissions. Clean technologies help organizations reduce emissions while improving operational efficiency. They include carbon capture, energy-efficient equipment, smart manufacturing, and advanced monitoring systems. Organizations face challenges in renewable energy adoption, including capital investment requirements, infrastructure limitations, technology integration issues, regulatory barriers, and energy storage needs. Strategic planning is essential to overcome these challenges. Corporate renewable energy programs are part of broader sustainability strategies. They focus on emission reductions, energy cost management, ESG improvement, and climate leadership, demonstrating commitment to clean energy as a strategic asset. The future energy landscape will be shaped by transformative technologies, with renewable energy central to decarbonization efforts. Innovations like decentralized networks, smart grids, green hydrogen, and AI-powered energy management will drive the transition to a sustainable future. This chapter covered low-carbon economy principles, renewable energy technologies, green hydrogen and storage, smart grids and electrification, and procurement and clean tech. Renewable energy is foundational to a sustainable, low-carbon future. As governments and businesses intensify efforts to address climate change, carbon neutrality and net zero emissions have become central objectives within global sustainability strategies. Organizations worldwide are making ambitious commitments to reduce greenhouse gas emissions, enhance climate resilience, and support international climate goals. Carbon neutrality and net zero are often used interchangeably, but they represent different approaches to climate action. Both concepts focus on reducing greenhouse gas emissions, yet they differ in methodology, scope, and long-term sustainability objectives. Understanding these differences is essential for developing effective climate strategies and credible carbon management programs. Achieving carbon neutrality or net zero status requires a combination of carbon footprint measurement, emission reduction initiatives, renewable energy adoption, supply chain engagement, technological innovation, and strategic planning. This chapter explores carbon neutrality, net zero frameworks, climate action planning, target setting, carbon offsetting, transition pathways, and organizational climate leadership. Carbon neutrality occurs when greenhouse gas emissions generated by an organization, product, or activity are balanced by actions that remove or offset an equivalent amount of emissions. The goal is to achieve a net climate impact of zero. Carbon neutrality is increasingly adopted by organizations seeking to demonstrate environmental responsibility. By balancing what's emitted with what's removed or offset, organizations can claim net zero climate impact for their operations, products, or activities. Net zero refers to reducing greenhouse gas emissions as close to zero as possible and addressing only unavoidable residual emissions through carbon removals. Net zero is considered a more comprehensive climate objective than carbon neutrality, and many governments and corporations have adopted net zero commitments. Although related, carbon neutrality and net zero have important differences. Understanding these distinctions helps organizations establish credible climate commitments. While carbon neutrality provides a valuable starting point for climate action, net zero represents a deeper, more transformative commitment. Organizations should understand which framework aligns best with their ambitions and stakeholder expectations. Organizations adopt net zero strategies for a wide range of strategic, regulatory, and reputational reasons. Net zero commitments increasingly influence corporate reputation and stakeholder confidence, making climate leadership a strategic business priority. Countries, cities, investors, and businesses worldwide are establishing net zero commitments. Global climate goals require significant emission reductions across all sectors, and organizations play a crucial role in achieving these objectives. Climate action planning transforms commitments into measurable actions. A structured climate action plan helps organizations prioritize initiatives, allocate resources, manage risks, and demonstrate accountability and implementation effectiveness, giving organizations a clear roadmap for achieving climate goals. Before developing a climate action plan, organizations must establish a baseline. Accurate baselines improve target setting and performance evaluation, providing the reference points against which future progress is measured. A well-established baseline is the foundation of any credible climate strategy. Without accurate measurement of current emissions, organizations cannot set meaningful targets, track progress, or demonstrate the impact of their climate initiatives to stakeholders. Baselines should be verified, consistently measured, and updated as organizational boundaries change over time. Effective climate strategies require measurable targets. Well-defined targets improve accountability and performance management, ensuring that climate commitments translate into concrete action. Organizations often establish multiple target horizons to support continuous progress. Multiple target horizons allow organizations to monitor achievements over time and maintain momentum toward long-term net zero objectives. Science-based targets align organizational emissions reductions with climate science, helping ensure that organizational actions support global climate goals. Science-based approaches are increasingly recognized as best practice, providing a clear framework for organizations to strengthen climate leadership. A decarbonization strategy outlines how emissions will be reduced across organizational operations and value chain. Decarbonization plans provide structured pathways toward climate goals, allowing organizations to prioritize high-impact initiatives. Renewable energy is a key component of climate action planning. Renewable energy reduces emissions associated with purchased electricity, and many net zero programs prioritize renewable energy investments as a foundational strategy. Carbon offsets compensate for emissions through climate-positive projects. Offsets are generally used for residual emissions that cannot be eliminated immediately, and organizations should prioritize direct reductions before using offsets. Offset project types provide different environmental benefits, and project quality is critical for credibility. Organizations should evaluate offset projects carefully to ensure they deliver genuine, measurable, and permanent climate benefits. Carbon removal involves extracting carbon dioxide from the atmosphere. Carbon removals are expected to play an increasing role in net zero strategies as technology development continues accelerating. Climate action planning should address climate-related risks. Organizations increasingly integrate climate risk assessments into strategic planning, and risk management improves resilience and preparedness. Successful climate programs require collaboration. Stakeholder engagement improves implementation success, and collaboration accelerates sustainability outcomes. Organizations benefit from shared climate objectives that extend across their entire value chain. Climate action plans require ongoing performance monitoring. Regular reporting improves transparency and accountability, and performance data support continuous improvement across all climate initiatives. Organizations may face significant challenges on the path to net zero. Addressing these challenges requires innovation, collaboration, and long-term commitment. Continuous improvement remains essential for sustained progress. Future climate strategies will increasingly utilize advanced technologies and innovative approaches. Organizations that embrace climate leadership will be better positioned for long-term success as the global economy transitions to net zero. This chapter provided a comprehensive exploration of carbon neutrality, net zero strategies, and climate action planning, the foundational frameworks guiding organizational climate leadership today. As organizations work toward carbon neutrality and net zero commitments, many encounter emissions that cannot be immediately eliminated through operational improvements or technological solutions. While direct emission reductions remain the highest priority, carbon offsetting and carbon market mechanisms provide additional tools to address residual emissions and support broader climate action. Carbon offsetting is the practice of compensating for greenhouse gas emissions by supporting projects that reduce or remove emissions elsewhere. Offsets help organizations address residual emissions while broader decarbonization efforts continue, and should complement, not replace, direct emission reductions. Many organizations face significant challenges in completely eliminating emissions across their operations and value chains. Carbon offsets provide a critical bridge while long-term decarbonization strategies are implemented. A carbon credit represents a verified reduction, avoidance, or removal of greenhouse gas emissions. Carbon credits can be purchased and used to demonstrate an organization's own emissions reductions or to balance carbon offset markets. Carbon credits are generated through approved climate projects that must meet rigorous standards before credits are issued and made available for trading within carbon markets. Various project types generate carbon credits, each contributing to climate action in different ways. Organizations often select projects based on their sustainability priorities, co-benefits, and alignment with corporate values. Renewable energy projects reduce emissions by replacing fossil fuel-based electricity generation with clean alternatives. These projects generate carbon credits by avoiding greenhouse gas emissions that would otherwise have been produced. Forests play a vital role in carbon sequestration, absorbing carbon dioxide from the atmosphere and storing carbon within biomass, soil, and organic matter. Nature-based solutions contribute significantly to climate mitigation. Preventing deforestation can generate substantial climate benefits. Forests store enormous quantities of carbon, and their destruction releases that carbon rapidly into the atmosphere. Conservation projects protect these vital areas. Methane is a highly potent greenhouse gas, approximately 80 times more powerful than carbon dioxide over a 20-year period. Methane capture projects target significant emission sources across multiple sectors, delivering outside emissions per ton of gas captured. Carbon removal projects actively remove carbon dioxide from the atmosphere, going beyond emission avoidance to deliver net negative emissions. These approaches are increasingly important for achieving long-term net zero and net negative climate goals. Additionality is one of the most important, and most scrutinized, concepts in carbon offsetting. It is the cornerstone of environmental integrity in carbon markets. Carbon projects must be carefully monitored and verified throughout their life cycle. Robust MRV systems are the backbone of credible carbon markets, ensuring that every credit issued reflects a genuine emission reduction. Voluntary carbon markets allow organizations and individuals to purchase carbon credits voluntarily, outside of any legal requirement, to support climate goals and carbon neutrality commitments. Market participation continues growing globally as corporate climate ambitions intensify. Compliance markets operate under government regulations, creating legally binding obligations for covered entities. Unlike voluntary markets, participation is mandated by law, and non-compliance carries significant financial penalties. An emissions trading system establishes a market-based approach to controlling pollution by providing economic incentives for achieving reductions in the emissions of pollutants. Cap-and-trade systems establish an overall emission limit for covered sectors, then allow market forces to determine the most cost-effective path to achieving that limit. Carbon pricing assigns a financial value to greenhouse gas emissions, making the cost of carbon pollution visible in economic decision-making. This alignment of economic incentives with climate objectives is a powerful driver of low-carbon investment and innovation. Organizations should carefully understand the potential risks associated with carbon offsetting before making commitments. Poorly managed offset programs can expose organizations to reputational, financial, and regulatory risks. Effective offset strategies integrate carbon credits into broader climate programs with rigorous governance, transparency, and a clear commitment to prioritizing direct emission reductions above reliance on offsets. Carbon markets are expected to play an increasingly important role in global climate action as ambitions intensify and technologies mature. Innovation will continue improving market integrity, transparency, and effectiveness. Net zero strategies offset unavoidable emissions after all feasible reductions have been achieved through available technologies or operational improvements. However, the role of offsets within a net zero strategy must be carefully defined and limited. This chapter provided a comprehensive foundation in carbon offsetting, carbon markets, and emissions trading systems, essential knowledge for sustainability professionals and climate leaders navigating the transition to a net zero economy. Environmental sustainability is a critical consideration for leaders worldwide. Organizations are increasingly expected to demonstrate transparency regarding their environmental impacts, climate risks, and greenhouse gas emissions. ESG reporting and climate disclosures are essential components of modern corporate governance and sustainability management, enabling organizations to communicate carbon footprints, reduction strategies, climate goals, and environmental performance to stakeholders. ESG reporting involves disclosing information related to environmental, social, and governance performance. It strengthens accountability and trust, with organizations integrating ESG reporting into core business strategies. Key areas include environmental impacts, social responsibility, governance practices, and sustainability initiatives. The environmental pillar focuses on how organizations manage their environmental impacts. Carbon footprint management is central, influencing investment and purchasing decisions. Key areas include GHG emissions, energy consumption, water management, waste reduction, climate risks, and carbon reduction. Climate disclosure communicates how organizations address climate-related risks and opportunities. Increased transparency, improved investor confidence, better risk management, enhanced stakeholder trust, and stronger sustainability performance are key benefits. Sustainability reporting helps organizations communicate their environmental and climate performance. It builds stakeholder engagement, supports ESG evaluations, informs investor assessments, ensures regulatory compliance, and manages reputation. Carbon reporting focuses on greenhouse gas emissions and climate performance. It enables organizations to track emissions, manage progress, and strengthen accountability. Key areas include direct and indirect emissions, carbon reduction initiatives, net zero commitments, climate targets, and performance tracking. Comprehensive carbon reports provide stakeholders with a complete picture of an organization's climate performance. Key elements include organizational overview, emission inventory, reporting boundaries, emission calculations, reduction initiatives, and climate goals and KPIs. Several internationally recognized standards support carbon reporting. Standardized reporting improves consistency and comparability, enhancing credibility through recognized methodologies like the Greenhouse Gas Protocol, ISO standards, and national regulations. Climate change creates significant financial risks for organizations. Understanding and disclosing these risks supports better decision-making and long-term resilience. Physical risks include flooding and drought, while transition risks involve regulatory changes and market transformation. Climate action creates opportunities for sustainability value creation. Renewable energy investments, sustainable products, resource efficiency, and innovation offer competitive advantages and attract talent. Materiality refers to identifying sustainability issues that matter most to stakeholders and organizations. Materiality assessments help prioritize reporting efforts, making reports more relevant and meaningful. Stakeholders increasingly expect detailed, credible climate information. Organizations must address stakeholder concerns through transparent reporting, improving trust and engagement across all groups. Organizations use key performance indicators to measure and communicate climate performance. Performance indicators support monitoring and continuous improvement, aiding strategic decision-making. Organizations increasingly disclose net zero commitments, carbon neutrality goals, reduction targets, and progress updates. Transparent reporting demonstrates accountability, and stakeholders can evaluate climate performance over time. Supply chain emissions are becoming increasingly important in comprehensive carbon reporting. Organizations gain greater visibility into indirect emissions through transparency, improving lifecycle carbon management across the entire value chain. Third-party assurance provides independent confirmation that reported data is accurate, complete, and consistent with recognized sustainability reporting programs. Assurance supports trust and accountability, giving stakeholders confidence in the accuracy of disclosed data. Modern organizations increasingly use digital technologies to streamline and enhance sustainability reporting. Digital tools improve efficiency and reporting accuracy, and technology supports real-time sustainability management across the enterprise. Governments and regulators worldwide are expanding climate reporting requirements. Organizations must prepare for evolving regulatory landscapes, and proactive reporting improves compliance readiness and reduces regulatory risk. While the benefits of ESG and carbon reporting are clear, organizations may face significant challenges in implementation. Addressing these challenges requires robust systems, strong governance, and a commitment to transparency. Future reporting systems will be transformed by technology, delivering deeper insights and greater transparency. Technology will continue transforming environmental transparency, and organizations will gain sophisticated sustainability intelligence. Carbon reporting is no longer simply a compliance activity. It has evolved into a powerful strategic tool. Organizations that effectively communicate climate performance gain strategic leadership and long-term resilience. This chapter explored the full landscape of ESG reporting, climate disclosures, and carbon sustainability reporting, from foundational concepts to future technologies. As organizations advance in their carbon management journeys, they discover that the majority of greenhouse gas emissions originate not from direct operations, but throughout the value chain, spanning suppliers, transportation providers, contractors, customers, product usage, and end-of-life activities. These indirect emissions are classified as Scope 3 emissions. For many industries, Scope 3 emissions account for more than 70% of total organizational greenhouse gas emissions. This chapter explores Scope 3 categories: value chain accounting, supplier engagement, sustainable procurement, decarbonization strategies, and future trends. Scope 3 emissions are indirect greenhouse gas emissions that occur throughout an organization's value chain. Unlike Scope 1 and Scope 2 emissions, they originate from activities not directly owned or controlled by the organization, yet they often represent the largest portion of an organization's carbon footprint. Without Scope 3 management, organizations may significantly underestimate their climate impacts. Comprehensive carbon accounting requires full value chain visibility. The business case is clear. They often represent the majority of total emissions. Investors expect full transparency. ESG frameworks increasingly require Scope 3 reporting. Net zero goals depend on value chain reductions, and supply chain risks directly affect business resilience. The Greenhouse Gas Protocol identifies 15 Scope 3 categories, divided into upstream and downstream activities. Understanding these categories supports comprehensive supply chain emissions management. Purchased goods and services are often the largest Scope 3 category for most organizations. Supplier activities generate significant emissions that extend beyond the reach of the organization, making sustainable sourcing a powerful lever for carbon reduction. Capital goods include long-term assets purchased by organizations. Manufacturing these assets generates greenhouse gas emissions that must be accounted for in Scope 3 reporting. Organizations increasingly consider life cycle impacts when making investment decisions. Transportation contributes significantly to Scope 3 emissions. Supply chain logistics often involve complex global transportation networks spanning multiple modes and geographies. Efficient logistics strategies are among the most impactful tools for reducing carbon impacts. Business travel remains an important source of indirect emissions. Organizations increasingly monitor travel emissions and implement reduction strategies, while virtual collaboration tools offer meaningful alternatives to in-person meetings. Employee commuting contributes to organizational Scope 3 emissions. The total impact depends on distance traveled, transportation mode, and vehicle efficiency. Employee engagement is essential to making commuting reduction programs effective. Waste generated by operational activities creates indirect emissions through disposal, transportation, and treatment processes. Circular economy approaches improve resource efficiency and reduce the carbon burden of waste streams. Many products generate emissions during customer use. For some industries, particularly automotive, electronics, and industrial equipment, product use emissions represent the largest Scope 3 category. These emissions can have substantial downstream climate impacts for years to come. Products continue generating environmental impacts after their useful life ends. End-of-life management significantly influences overall lifecycle emissions. Organizations incorporate circular economy principles into product development to minimize these impacts. Supply chain carbon footprinting quantifies emissions generated throughout supplier networks. It provides the visibility organizations need to identify major emission hotspots and prioritize decarbonization investments where they will have the greatest impact. Effective Scope 3 management requires genuine supplier collaboration. Organizations that invest in strong supplier relationships accelerate decarbonization efforts across their entire value chain, turning suppliers from passive actors into active climate partners. Procurement decisions are among the most powerful levers organizations have to influence their Scope 3 footprint. Responsible sourcing supports climate goals while also building supply chain resilience and improving overall stakeholder expectations. Supplier assessments help evaluate environmental performance across the value chain. They improve transparency, accountability, and organizational insight into value chain risks, establishing a new standard for engagement and investment. Supply chain decarbonization focuses on systematically reducing value chain emissions. It requires coordinated action across multiple dimensions, from raw materials to logistics and circular economy design. Value chain improvements are essential to achieving net zero objectives. Renewable energy adoption can significantly reduce supplier emissions throughout the value chain. Organizations increasingly encourage and require suppliers to transition to clean energy, extending climate benefits across entire supply networks. Organizations often face significant difficulties when collecting Scope 3 information. Improving data quality remains a major strategic priority, and technology solutions are increasingly helping address these challenges at scale. Modern organizations increasingly leverage digital technologies to improve visibility, efficiency, and control over value chain emissions. These tools are transforming Scope 3 management from a manual, fragmented process into a data-driven, real-time capability. Climate-related risks can significantly affect suppliers and logistics networks. Understanding these risks improves organizational resilience and enables better preparation for future challenges, both physical and transitional. The future of Scope 3 management will be defined by automation, real-time data, and digital traceability. Technology will fundamentally improve supply chain transparency and emissions management, giving organizations deeper visibility into value chain impacts than ever before. Organizations cannot achieve net zero alone. Sustainable supply chains and Scope 3 emission reductions are essential for meaningful climate action. This chapter covered key concepts, categories, carbon footprinting, procurement, engagement, decarbonization strategies, and future trends. Carbon footprint management is crucial across various sectors, including manufacturing, transportation, energy, and industrial sectors. Each sector contributes to greenhouse gas emissions through its unique activities and processes. By maintaining consistent carbon management practices, organizations can address climate challenges effectively. Different industries generate emissions differently, necessitating industry-specific carbon management strategies. By focusing on sector-specific factors, organizations can effectively reduce emissions and enhance sustainability. Manufacturing is a significant contributor to greenhouse gas emissions. By implementing carbon management programs, manufacturers can enhance sustainability through energy efficiency and process optimization. Energy consumption in manufacturing is a major concern. By combining energy efficiency measures with renewable energy adoption, organizations can significantly reduce their energy footprint. Industrial processes generate emissions independent of energy use. Addressing these emissions requires targeted reduction strategies and technological innovation. Sustainable manufacturing strategies improve both environmental and operational performance. By optimizing processes and integrating renewable energy, organizations can achieve significant cost savings and emission reductions. Transportation is a major source of greenhouse gas emissions. Addressing these emissions is essential for achieving climate goals, requiring innovative solutions across all transportation modes. Road transportation significantly contributes to carbon footprints. By evaluating low-carbon alternatives, organizations can reduce emissions from major sources like passenger vehicles and commercial trucks. Fleet carbon management programs enhance operational efficiency and environmental performance. By improving fuel efficiency and optimizing vehicle maintenance, organizations can significantly reduce emissions. Electric vehicles play a crucial role in transportation sustainability. By reducing emissions and lowering fuel costs, they offer significant environmental and economic benefits. Aviation faces unique challenges in decarbonization. By adopting sustainable fuels and improving aircraft efficiency, the industry can reduce its carbon footprint significantly. Maritime shipping supports international trade but generates significant emissions. By adopting fuel-efficient technologies and alternative fuels, the sector can enhance sustainability. The energy sector is a major contributor to global emissions. By transitioning to low-carbon alternatives, significant reductions in carbon footprints can be achieved. Fossil fuels remain a major contributor to greenhouse gas emissions. Reducing reliance on these fuels is crucial for a sustainable energy future. Renewable energy technologies offer a sustainable alternative to fossil fuels. By harnessing solar, wind, and other renewable sources, organizations can reduce emissions and enhance energy security. Construction activities generate emissions through material production and operations. By adopting sustainable practices, the industry can significantly reduce its carbon footprint. Embodied carbon refers to emissions from building materials and construction processes. By selecting sustainable materials, organizations can reduce their carbon footprint significantly. Industrial facilities often generate substantial emissions. By optimizing processes and integrating renewable energy, the sector can achieve significant emission reductions. Carbon capture, utilization, and storage (CCUS) technologies capture carbon before it enters the atmosphere. These technologies offer opportunities for significant emission reductions across various industries. The circular economy reduces emissions by extending product life and improving resource efficiency. By adopting these principles, industries can achieve significant environmental and economic benefits. Organizations are leveraging benchmarking to enhance climate strategies. By evaluating performance against industry standards, they identify gaps and set realistic improvement targets. Learning from industry leaders helps adopt proven strategies and identify measurable reductions. Using benchmark data, organizations track progress and refine their sustainability positioning. Digital tools are transforming carbon management. Automated platforms handle data collection and reporting, while AI optimizes energy consumption. Smart sensors gather real-time data, and advanced analytics provide actionable insights for strategic management. Innovation is key to reducing carbon emissions. Advanced electrification and AI-powered management optimize energy use. Green hydrogen and CCUS expansion are crucial for industrial transformation, while smart systems integrate digital and physical operations. This chapter covered key topics in carbon management, including industrial emissions, carbon capture, and future trends. Each area offers unique opportunities for sustainable development and climate action. Environmental sustainability is now a strategic priority for organizations worldwide. Investors, regulators, employees, and financial institutions increasingly expect businesses to adopt responsible management and sustainable practices to achieve long-term competitiveness. ESG provides a comprehensive framework for evaluating organizational sustainability performance. Organizations increasingly integrate ESG into strategic planning and reporting processes. Sustainability performance increasingly influences business success across every industry sector. Investors, customers, regulators, and employees are all demanding stronger ESG practices. The environmental pillar focuses on managing the environmental impacts of organizational operations. Carbon footprint management is one of the most relevant environmental performance indicators. Carbon emissions are widely recognized as a critical ESG indicator. Transparent reporting strengthens accountability and trust with all stakeholder groups. Climate change is no longer viewed solely as an environmental issue. It has become a core strategic consideration that affects every dimension of organizational performance. Corporate sustainability focuses on creating long-term value while minimizing environmental and social impacts. Companies increasingly align sustainability programs with climate goals. Executive leadership plays a critical role in driving climate action. Strong leadership accelerates sustainability transformation and shapes organizational culture and performance. Boards of directors increasingly oversee climate-related issues as part of their fiduciary responsibilities. Board engagement improves governance and accountability, and climate oversight is becoming a governance best practice worldwide. Climate governance establishes the structures, policies, and processes for managing environmental performance. Effective governance strengthens carbon management programs and gives organizations greater control over climate-related risks. Stakeholders increasingly demand climate transparency and measurable progress toward sustainability goals. Transparent communication improves stakeholder trust and strengthens organizational reputation. Organizations disclose climate information through ESG reports and sustainability disclosures. Reporting improves transparency and accountability, giving stakeholders meaningful insight into organizational climate performance. Climate risks can significantly affect organizational performance, financial results, and long-term viability. Managing climate risks improves resilience and preparedness across the enterprise. Climate action creates significant business opportunities for organizations that move proactively. Organizations that embrace sustainability often gain competitive advantages and create long-term value. Financial institutions increasingly evaluate climate performance when making investment and lending decisions. Strong sustainability performance can improve access to capital, while poor environmental performance raises the cost of financing. Organizations increasingly establish structured carbon reduction targets that provide direction, accountability, and a framework for continuous improvement. Climate targets are often integrated into broader sustainability strategies and linked to executive compensation. Employees play an important role in carbon reduction initiatives. Organizational culture significantly influences sustainability success, and engaged employees are essential to achieving climate goals. Supply chains significantly influence ESG performance. For most organizations, Scope 3 supply chain emissions represent the largest portion of their total carbon footprint. Carbon considerations are increasingly integrated into core business decisions across every function. Organizations that embed climate thinking into decision-making gain better visibility into environmental impacts and make choices that improve long-term value creation. Organizations use key performance indicators to monitor sustainability performance, support accountability, and drive continuous improvement. Reliable data strengthens reporting credibility and sustainability outcomes. The future of ESG governance will be defined by technology, data, and real-time accountability. Organizations will gain unprecedented visibility into sustainability performance, enabling faster and more informed climate action. Carbon management is no longer limited to environmental departments. It has become a core strategic business capability that influences every dimension of organizational performance. This chapter explored the critical relationship between carbon footprint management, ESG performance, corporate sustainability strategies, governance frameworks, and long-term value creation. As organizations pursue ambitious climate goals and net zero commitments, managing greenhouse gas emissions has become increasingly complex. Modern businesses operate across global supply chains, multiple facilities, transportation networks, and diverse operational systems that generate vast quantities of environmental data. This chapter explores digital carbon management systems, sustainability software platforms, AI-powered analytics, smart technologies, environmental intelligence systems, and future climate technology innovations. Digital carbon management uses technology to improve carbon accounting and climate performance management, providing organizations with better visibility into greenhouse gas emissions and enabling faster, more reliable sustainability management. Modern organizations generate environmental data from numerous sources. Managing large datasets manually can be inefficient and prone to errors. Digital solutions simplify data collection and reporting processes, giving organizations better control over sustainability performance. Carbon management software centralizes sustainability information and improves reporting consistency, enabling organizations to manage emissions more efficiently across multiple locations and operations. Cloud technologies provide scalable sustainability management solutions that support global organizations managing emissions across multiple regions. Data can be accessed securely from anywhere, enabling real-time collaboration and decision-making. Artificial intelligence is transforming sustainability management by processing large volumes of environmental data quickly and accurately, enabling organizations to gain deeper sustainability insights and move from reactive reporting to proactive climate management. Machine learning algorithms identify patterns within environmental datasets that would be impossible to detect manually. This improves decision-making and forecasting capabilities, enabling organizations to proactively address climate-related challenges. Sustainability management increasingly relies on big data analytics to transform raw environmental information into actionable insights. Organizations gain comprehensive visibility into environmental performance across all operations. IoT technologies enable real-time environmental monitoring by continuously collecting environmental information. Organizations can identify inefficiencies and respond quickly to issues, supporting proactive carbon management. Energy management systems help organizations optimize energy use, reduce waste, and improve efficiency. Energy optimization contributes significantly to carbon reduction efforts across facilities and operations. A digital twin is a virtual representation of a physical asset, process, or system. Digital twins allow organizations to evaluate sustainability improvements before implementation, making decision-making more effective and data-driven. Automation reduces manual effort in sustainability reporting, improving accuracy and consistency while significantly reducing reporting time and administrative burden for sustainability teams. Blockchain technology enhances transparency and traceability in sustainability management. By creating immutable, distributed records, blockchain improves data confidence by strengthening data integrity and making environmental information more reliable and transparent. Digital product passports provide lifecycle sustainability information, supporting circular economy initiatives and product transparency. Stakeholders gain better access to sustainability information throughout a product's entire lifecycle. Predictive analytics uses historical and real-time data to forecast future outcomes, enabling organizations to evaluate future scenarios and prepare accordingly. Predictive carbon analytics streamline strategic planning and accelerate decarbonization. Climate-related risks are becoming increasingly important for organizations across all sectors. AI systems improve organizational resilience by making risk management more proactive and data-driven. Modern ESG reporting increasingly relies on digital platforms that enable organizations to respond more effectively to stakeholder expectations while improving reporting quality and efficiency. Digital technologies improve visibility across supply chains, enabling organizations to gain better control over Scope 3 emissions, which typically represent 70–90% of a company's total carbon footprint. As sustainability systems become increasingly digital, protecting environmental data becomes critically important. Strong cybersecurity supports reliable sustainability management, and stakeholder trust depends on secure information systems. While digital carbon management offers significant benefits, organizations may encounter increasing challenges during implementation. Successful adoption requires careful planning, investment, and strategic approach. Continuous improvement is key to success. Technology will continue transforming carbon footprint management and climate action. Organizations embracing innovation will gain competitive advantages in the transition to a low-carbon economy. Digital technologies are becoming essential for achieving net zero objectives. Organizations that combine sustainability expertise with digital innovation can accelerate climate action and improve environmental performance. Digital transformation strengthens climate leadership. This chapter explored the vast potential of digital technologies transforming carbon management and climate action, from foundational carbon software platforms to cutting-edge AI and quantum computing applications. Carbon footprint management has evolved from a voluntary environmental initiative into a strategic business necessity. Organizations are now recognizing that climate change is not only an environmental issue but also an economic, operational, financial, and governance challenge. Emerging technologies, climate leadership, professional practice, and a low-carbon future are reshaping sustainability. Carbon management has changed significantly over recent decades. Initially focused on basic emissions reporting, modern carbon management now encompasses a far broader strategic scope. Organizations increasingly view it as a core business function where environmental performance directly influences competitiveness and resilience. Several powerful global trends are influencing future carbon management practices. Climate action is rapidly becoming a universal business requirement, and organizations must adapt to rapidly changing expectations from governments, investors, and consumers alike. Many countries, cities, and organizations have adopted net zero commitments, signaling a fundamental shift in how economies are structured. These shifts will influence interconnections between sectors, supply chains, and business models for decades to come, and organizations must prepare for this long-term transition. Artificial intelligence is expected to revolutionize sustainability management, enabling faster and more accurate decision-making. Organizations gain powerful tools for managing environmental performance at a scale and speed previously impossible with manual methods. Future carbon management will increasingly rely on advanced analytics capabilities that transform raw emissions data into actionable strategic intelligence. Data-driven sustainability strategies consistently improve outcomes and enable organizations to identify risks and opportunities before they occur. Traditional reporting often relies on historical information compiled weeks or months after the fact. Future systems will increasingly provide live visibility into emissions performance, enabling organizations to respond more rapidly to environmental challenges and operational inefficiencies. Renewable energy will continue expanding globally at an accelerating pace. Organizations increasingly depend on renewable energy to achieve their sustainability targets, and renewable systems form the backbone of long-term decarbonization efforts across various sectors. Green hydrogen is expected to become a major climate solution, particularly for sectors where direct electrification is technically or economically challenging. Investment in hydrogen innovation continues increasing as governments and corporations recognize its transformative potential. Carbon removal will play an important role in future climate strategies, particularly for addressing residual emissions that cannot easily be eliminated through efficiency improvements or direct emissions reductions. Various technologies are being developed to capture and store carbon effectively. Investors increasingly evaluate environmental performance as a core component of financial analysis. Organizations with strong sustainability programs may gain improved access to capital, lower borrowing costs, and preferential treatment from institutional investors, making climate finance a major driver of corporate strategy. Carbon markets are expected to expand significantly in scope, liquidity, and geographic coverage. Organizations must understand evolving market mechanisms to leverage carbon trading as part of their broader decarbonization strategy. Digital product passports will provide detailed sustainability information throughout product lifecycles, enabling consumers, regulators, and supply chain partners to access verified environmental data at every stage. Transparency will become increasingly important as circular economy objectives gain regulatory support. Future carbon management will require deeper supply chain visibility than most organizations currently possess. Technology will improve transparency throughout global value chains as Scope 1 and Scope 2 management becomes increasingly sophisticated at data scalability and quality improvement. Climate risks will continue affecting organizations worldwide through both physical impacts and transition pressures. Future climate management programs will integrate resilience planning and risk management as core functions, helping organizations prepare for an increasingly uncertain environment. ESG reporting and sustainability governance will continue evolving as regulatory requirements strengthen and stakeholder expectations rise. Organizations with strong ESG performance are likely to benefit from increased stakeholder trust, improved access to capital, and enhanced brand reputation. The role of carbon management professionals is rapidly evolving beyond traditional environmental compliance into a multidisciplinary strategic function. Continuous learning will be essential for professional success as organizations increasingly seek experts who can bridge technical, financial, and strategic domains. Demand for climate and sustainability professionals continues growing across all sectors of the global economy. Career opportunities are expected to expand significantly as organizations scale up their sustainability programs and regulatory requirements intensify. Innovation will remain essential for achieving climate goals, particularly in sectors where existing technologies are insufficient to reach net zero targets. Organizations that embrace innovation will accelerate sustainability performance and gain competitive advantages in the emerging low-carbon economy. Long-term success in carbon management requires deep organizational commitment that goes beyond policies and targets. Organizations that integrate sustainability into their culture often achieve stronger and more durable outcomes, because climate action becomes part of everyday decision-making at every level. In the transition to a low-carbon future, leaders must grasp climate science, carbon management, and sustainability strategies. This foundation supports balancing environmental, social, and economic priorities. The future of carbon management involves AI-powered decisions, net-zero operations, resilient supply chains, renewable systems, and global transparency. Embracing these trends positions organizations for success in a sustainable economy. Congratulations on completing the course. You've gained skills in carbon assessments, strategy development, ESG reporting, and leading sustainability transformations. These capabilities are crucial for driving organizational change. Completing this course equips you with the skills to lead in carbon management and sustainability. From carbon assessments to renewable energy leadership, you're prepared to drive impactful change. If you wish to undergo a complete professional course on this subject and earn a recognized certification, visit CDG Training and enroll in the Advanced Carbon Footprint Management and Reduction Professional Program. The course is fully online, allowing you to access the course from anywhere in the world using any internet-connected device. It offers self-paced study, letting you learn at your own pace with maximum flexibility and convenience. You can also take the online examination at your convenience and receive your professional certification digitally upon successful completion. Check the course link in the video description to access the enrollment page directly. Your entire learning experience, from course access to study materials, examination, and certification, is completely online and automated. The fully automated system ensures fast certification processing and seamless global accessibility. From the moment you enroll, every step of your journey is handled digitally, no paperwork, no delays, no barriers. Study when it suits you, sit your exam when you are ready, and receive your professional certification instantly upon successful completion. Visit the CDG Training official website to enroll, get certified, and advance your career as a recognized sustainability professional. Why enroll now? Gain globally recognized professional certification, immediate course access upon enrollment, and a flexible, self-paced online format. Digital certificates are delivered instantly. Navigate to the Advanced Carbon Footprint Management and Reduction Professional course page, complete the simple enrollment process, and gain immediate course access. Complete your studies, pass the online examination, and receive your professional certification. We want to support your journey toward becoming a globally recognized advanced carbon footprint management and reduction professional. Your commitment to sustainability will help shape a cleaner, more resilient, and sustainable future. Advanced greenhouse gas accounting, carbon footprint assessment, and climate-focused sustainability leadership are key components of our program. AI-powered carbon analytics, ESG reporting systems, and sustainability performance monitoring are integral to our curriculum. Drive environmental responsibility through carbon reduction, climate action, renewable energy adoption, and responsible consumption. CDG Training, empowering professionals. Advancing sustainability. Transforming the future.